We can see from the definition of distance or finding distance that we need to be able to find the integral of an absolute value. And I kind of went over it really quickly right here, but I want to review it as this is something you were supposed to have learned in Calc 1, but I find not everybody picked it up or understood what their professors were talking about at the time. So let's see if we can go over it together. So we're going to find the integral from 0 to 5 of the absolute value of this function. So not f of x, but its absolute value. So the first thing I want to do is I actually want to take the time to find out what f of x is in written out form for my own reasons. So if I FOIL the two binomials, it's x squared minus 5x minus 3x, which is minus 8x plus 15. That would be x cubed minus 8x squared plus 15x. So I'm just going to make a note of that. It didn't ask me to do that. I just wanted to have it for later. All right, so now I would want to know where this particular function is equal to 0. So let me grab a different color here. So also note, and luckily for us, this was factored in the first place. So if f of x is equal to x times x minus 3 times x minus 5, that means that x equals 0, x equals 3, and x equals 5 are the solutions, right? So if you set this equal to 0, the three spots that would make it 0 are 0, 3, and 5. And this was easy because this was pre-factored for us. If it wasn't factored, we'd have to do more work. All right. Now, how does that help us? Well, because now we can find the integral. So if we want the integral from 0 to 5 of the absolute value of f of x. Oh my gosh, dx, not dt. Goodness gracious. I don't have the graph of that. I have the graph of f of x, right? This is f of x, no question about it. The absolute value of f of x would actually have a little peak here. Kind of go like this. So it would have a sharp point here and a sharp point here. No, I'm not a perfect drawer, right? So we have this positive part here, which is from 0 to 3. That would be like it normally was, right? And then we're going to have an extra part over here, which is going to be from 3 to 5, right? Okay, so now how do we break this down? So to work this, we're going to take our integral and we're going to break it into two pieces. We're not allowed to integrate across this cusp like this. So what we're going to do is we're going to take the integral from 0 to 3 of our function. Oh, let me write it over here. From 0 to 3 of f of x dx plus, and then I'm going to take another integral from 3 to 5, but it's actually going to be the opposite, the negative of f of x. That's how it's going to cause it to go up like that. Okay, so I'm going to go from 0 to 3 of f of x, which was x cubed minus 8x squared plus 15x. Now we see why I did it. And you have a choice here. It's a little notational choice. It's either you take the negative and distribute it to each one of these, or you put a minus in front of the whole thing. Now you might think, oh, a minus in front will be easier. Not necessarily, because you'd have to subtract whatever number you get. So it's kind of whatever you want to do. So I'm just going to add it to the integral from 3 to 5. It'll be negative x cubed plus 8x squared minus 15x. It takes every sign from f of x and it makes them negative. So here's f of x, here's negative f of x. And again, the other option is to turn this plus sign into a minus sign, and that's totally valid if you want to do that, no problem. Okay, so then I want to integrate each one of these. So this would be 1/4 x to the 4th minus 8/3 x to the 3rd plus 15 halves x squared from 0 to 3 plus, and it'll be the same thing. It'll be negative 1/4 x to the 4th plus 8 thirds x to the third minus 15 halves x squared from 3 to 5. Okay, so putting 3 in, putting 0 in. 0 in is easy. 0 is no problem, right? So, but I can go 1/4, 3 to the 4th, minus 8 thirds times 3 to the third, plus 15 halves, 3 squared, minus 0, right? Because 0 going into all of those makes 0. So that's easy. And then I'm going to add to it. That's why I don't want the negative there, because it just makes things more difficult. But I'm going to add to it, and then I have to do all of this. So negative 1/4 times 5 to the 4th plus 8 thirds times 5 to the third minus 15 halves times 5 squared minus, and I don't have to worry about should I bracket all of this or not, because the answer is you should, but since it's plus here, it doesn't make any difference. Oh, and then I'm running out of space. I'm going to have to put it down here. Sorry, because I won't be able to fit this in. So minus 1/4 times 3 to the 4th. Oh, sorry. There's a minus and a minus. Hold on. Minus negative 1/4 times 3 to the 4th plus 8 thirds times 3 to the third minus 15 halves times 3 squared. Every so often it's just satisfying to do stuff like this. Okay, so we don't want to have to do this by hand. This is what computers and calculators are invented for. So let's make this a little bit smaller. Let's bring the Desmos up. Give me 1 second. All right, I'm totally going to type this stuff in. All right, so 1/4 times 3 to the 4th minus 8 thirds times 3 to the third. Oop. And then plus 15 halves times 3 squared. Get us 15.75. Okay, so this number right here is 15.75. So 15.75 minus 0, so I don't have to worry about that, plus, I need this number. All right. Well, it'll be easy if I could just copy and paste this. I'm going to do it twice here. Oh, there is another way to do that. Let me show you. So if I go to the little gear and then I click duplicate, it'll make it twice. That's another way to do it besides copying and pasting, especially if it's longer. It's nice. All right, so these will be negative, positive, negative. Oh, heck, I should have duplicated that one. All right, so let me do this again. Let me duplicate that. Done. All right, so this will have 5 in it. And if you're thinking, hey, that other one already has everything we need, the answer is yes, it does. So this is 15.75. This is negative 15.75. And then this is negative 10.41666 repeating, which is negative 125/12 if you want to know, like that. Matter of fact, I think I'll use the fractions just for right now. So it'll be 63 over 4 plus a negative, that part right there is negative 125 over 12. And then minus, and then this, what I typed in there was another negative 63 over 4, right? Because this minus right here is this minus right here, right there. Okay, so I just need the computer to tell me what 63 divided by 4 minus 125 divided by 12 plus 63 divided by 4. And it tells me it's 21.083 repeating, which is 253 over 12. Lovely. Okay, probably more trouble than it's worth, but I wanted to review how to do this and show everybody all the work that's involved. You have to be very careful not to screw up your minus signs, which I almost did here, but don't mess up your minus signs. Don't mess up your notation. It's very important, right? So here's the whole first piece, and then here's the whole second piece. And if you keep a minus instead of a plus, it just makes this a little bit trickier down here. And that's one of the reasons I avoid it. But if I can. If I can't, then I'll just deal with the minus and be very careful about my notation.